Welcome everyone. My name is William, and thanks for joining our, what is it, Alessandro, our 15th, 7th meetup this year. I don't know. Today's topics are around DevOps and AI and platform engineering. We would like to thank, first of all, our sponsors and also the company I work for, ITQ and SUSE. Thank you very much for all the food, all the drinks, and the space. Your hosts, myself from SUSE, hello, and ITQ, again, thank you very much. Thank you. This is a meetup from the CNCF, therefore it boils down to the code of conduct of the CNCF. What it is, just treat the others like you would like to be treated, with respect, regardless of race, gender, perceived feeling of what somebody is. This is roughly the agenda, which we are already late on. We are going to have a talk from Johan at 7 o'clock. This is your welcome.
Not late.
Huh?
45, 30 minutes.
Yeah, so forget about the agenda. So then we're gonna have a welcome. This is the welcome. Then we're gonna have a talk from Johan that I'm really looking forward to. We're gonna have a 15 minutes break for toilets and some smokes for those that still have the habit. And then I'm going to be giving a talk about platform engineering. Then the dinner is going to be served in the other area at 8:15. But that 8:15 now, it's a little bit vague in the air because I made the agenda, so everything is. What is for sure is that we're leaving the room, the premises at 9 or before 9, if so you choose. There are two ambassadors in this room, and those are the people, two CNCF ambassadors in this room, and those are the people that you have to report any violation of code of conduct, or that you might give compliments to. Compliments you can give to me, the violation of code of conduct you can give to the guy dressed in black. And with this, then what's next? Yes, there are some things happening. There are KCDs, the Kubernetes Community Days, that are on hold until 2025. Some are allowed to occur in 2024, but we are holding on the KCDs. The bad news is that we might not do the one in the Netherlands this year, most likely. There is another meetup, HomeLab Cube in July. 18th of July. Nice. We have a date. If you're building a home lab, if you have a home lab and you really want to show off your geekiness, if you want to build just sync up with Alessandro. I know, Johan, you have something to say about it. Then there is the Tag Environmental Sustainability Week. That is in the 10th of October. It's a week for the whole, globally, where we organize sustainability meetups, sustainability talks, events, whatever. We try to be green. And if you have any ideas, just bring it up to the above mentioned Alessandro for the nasty ideas, and the nice ideas, you bring them to me.
CFP is open.
For the environmental sustainability?
Yes.
Nice. So if you have nice talks, bring them to me. Anyway, so to stay in touch with us, please join the Netherlands Slack channel. If you are a speaker, somebody wanted to speak about some stuff, so please join over there. Make yourself known to us. Join the CNCF Amsterdam community, and you can email us over there. Nobody will ever read it. And that was it. So, and I would like now to have,
yeah, I'm the
please,
guy with
Bert.
the shirt. I'm the only guy here with the shirt, right? Who has a shirt? Maybe a bit more. I'm still wearing sneakers, though this means that I'm sales, but a bit of technical sales. So let me switch. By the way, it was the first time that I actually used a TLD.m stand, right? Nobody uses that.
Okay. I'm sorry, I wasn't mine.
So,
Would you like to turn on your mic?
it's on.
All right.
Yeah.
Cool.
Thanks for raising the expectation, Bert, because up till a couple of months ago, I had no idea what Kubernetes was. And honestly, I still don't. So I could either be at completely the wrong place or share some of the, things I learned in the last couple of months. But before we dive into the session, I would like to introduce ITQ first. And I'm going to go quite quickly through the first slides. So we were like, I think we were started in 2001, 23 years ago, because our two founders kind of figured out they were doing professional services in the infrastructure space for quite a while for different companies, but whatever they did, the quality of the stuff they did was not the primary concern, and also the money they earned, the companies earned, wasn't put back into the employees of the company. And that's what the idea was. Like, let's start a new company where we can do IT much better, way better and faster, but also with that queue of quality in mind. And every, I think guilder back then still, or euro, we earned, went back into the company. So, and that's still what it is today. There's no foreign money there. It's all privately owned, and everything we earn is being put back into our employees. So we've been doing this for 20 plus years, and we've done that through the right skills, the right approach. So we think we have a unique approach, which I'll cover in a bit. And like, we started out with just customers in the Netherlands. We were in a small office in Wijk aan Zee, and our customers were pretty much somewhere in the Netherlands, but in the last couple of years, and I'll share 3 customers later in the presentation, we've been working through, well, basically the entire world. It says Europe here, but many of our consultants have been spending time in the Middle East or in the US even, and so that's pretty cool for such a, well, I would say small company, but you know. So we have I will go quickly through this, some milestones. Founded in 2001, 2015, we made a conscious decision to go full on VMware, but also Pivotal. So, it was kind of, 2 main focus areas. And luckily for us, VMware acquired Pivotal a bit later. So the whole Tanzu platform was originated. So in 2018, we started our first endeavor outside of the Dutch borders, opening up Belgium. And in 21, we did a similar thing, but then in Germany. In 22, we opened up ITQ Luxembourg, and in 22 as well, we opened our France branch, which kind of ended our strategy in growing throughout the whole Europe, but also find the right people. That's I think from the VMware community where we all already active in, we noticed that a lot of really good people, really skilled people, but also with the same DNA, were somewhere across those regions and have now joined our family as well. So that's pretty cool. And well, it says 23, but officially it was, I think, 23, but effective this year. Yeah, we acquired one of our competitors, Com IT Solutions, who were active in the MSP space. So they deliver managed services to mainly hospitals throughout our country. And they're now also part of our portfolio. So the things that we do across 3 different main areas of expertise. We are active in the hybrid cloud space. I won't go into too much detail about this today, but we can do basically everything around public cloud, private cloud, and mostly from the infrastructure side of things. So we also do a lot of things around the digital workspace, and that's the space I've been active in the last 25 years. So I started my career in '99, always kind of mock in the late 90s, but it was literally December 1st, '99, so the latest in the 90s you could get. And I've been working with end users, listening to them complaining and kind of liked it for the last couple of years. So, but yeah. And I'll dive into that a bit later, but I made a conscious decision to change course and do something really awesome right now. And I think this is where it all is going to focus on in the upcoming time, but also now. Like we do a couple of things, and the landscape is quite complex, I would say, especially if you're an outsider like me, who was focused on Windows and applications installing inside Windows. The world was easy, but if you look at how the cloud native landscape, for instance, looks currently, it's for me kind of confusing-ish, but the journey is really cool, I must say, and I'll share a really cool story a bit later. So within the cloud native space, we do a couple of things. We talk to customers about the non-technical things. So how do you implement a DevOps philosophy or methodology? We're not going to talk about technology. We're just going to talk about like making a transition in your organization to develop in an agile way. We can implement and adopt technologies or build applications. We can help you with platform engineering, and I think that's one of the main topics why we're here today. But also, and that comes mainly from what we did with Pivotal before, is that like you can install or you can deploy a complete development suite and a platform, if you will. But if no one uses it or optimally uses it, it's still a challenge. So that's also one of the things that we focus on. We enable the developers to get the most out of their platform. Now, how we do that is through a methodology where we have 3 phases. We consult and envision, we build and implement, and we manage and improve. But again, I won't go into a lot of detail about that. We do it different. We know where you are. We know what you have, and we don't care. Honestly, we can help you with in any type of situation, and independent if that's like a matter of you call us and we help you with something, or in some cases, some of our colleagues are working multiple years with a customer to drive that digital transformation in a really cool way. And finally, we think we have a really cool culture because we do what we say what we do, and that's it. And that's really cool. Now, like I mentioned, we originated we were focused on just VMware. Well, that changed. And we are proud. Like last week, we officially announced a partnership with SUSE, something we're really proud of because I think it perfectly reflects the area that we are heading towards. The portfolio is broad, but we believe we can create true value at customers with that portfolio. It's not just about the technology anymore. No, we're not going to sell. Honestly, we're not going to sell Rancher. No, we're going to sell an outcome and Rancher is part of that. And I think that's one of the most awesome things I think about the partnership. Now, final slide. Final slide. So I would like to. So this is. So in the abstract, it says that the learning curve is very steep, quite comparable to bare hand climbing. In this case, anyone recognizes that mountain? Or the scene even.
Is it Capitan?
Yes. And there's a movie about El Capitan, about this guy climbing El Capitan for the 10th time, barehanded, without ropes. That's kind of how the learning curve for me into the world of Kubernetes felt. So I haven't introduced myself. My name is Johan van Amersfoort. I'm a chief evangelist at ITQ. I sit within our CTO office, and within the CTO office, I am responsible for listening to customers to like about how we can create value. It's not a sales role, so I just listen. But also, I like to take the learnings and the stuff I do from an R&D perspective and present, or blog, or create podcasts, or create content around the cool things that we're doing. I don't do that alone. I have really awesome colleagues like Robert and Rob here, who kind of join us in evangelizing our solutions. So anyone recognizes the thing?
Skunk.
Yeah. So skunk
From Disney.
from Disney. Yeah. Well, I heard that the other day. Someone mentioned the same, but no, it's not. So anyone seen this movie? That's the one. So this is Top Gun 2, Dark Star, fictive plane. But what's really cool is that if you look at the tail, there's a skunk there. So Skunk Works is the R&D department of Lockheed Martin. I'm a huge plane geek, or well, not just plane geek, but everything that has to do with jet fighters, with helicopters. I kind of find it awesome. And this is, to me personally, the most awesome plane ever built. Anyone recognize this or know? Exactly. So Martijn will hand you over swag later tonight for that. Now this is, and what's even more cool is that this guy, Kelly Johnson, was the first engineer at Skunk Works. And he was actually the lead of the team that created the SR-71. And what's even more cool is that that guy invented the 15 rules of engagement for Skunk Works. And following these rules, if you quickly go through these rules, so these rules are to date 70 years old, 72 years old. But if you literally go through them, it's like how we develop services and solutions nowadays. So he was, to me personally, he was ahead of his time, probably doesn't even cover it. So that's where the skunk comes from, because within our CTO office, we follow the same methodology to develop services and solutions. And we do that through R&D, lifecycle management, and evangelism. So what we take, so we do two things mainly. We have a product leadership strategy where we work with customers and build something because they want it. So like they need knowledge and they hire us to basically to build something or to help them with upgrading something or whatsoever. What quite often happens, and Rob here is, well, nice that you're here, by the way. Rob, I work with Rob at a large aircraft manufacturer, and there's only two, one in Europe. And what we did there was we built a image as code platform to rapidly build desktops, development desktops for roughly 16,000 developers. Before Rob did his magic, it took roughly 3 months before they could literally update the lifecycle of a base image. After we were done, it took 30 minutes. So, and what we have done is we took all of the knowledge and all of the stuff we did there and basically brought it into a managed service. And that's what we're currently focusing on, hence the skunk. Now, enough about the ITQ talk. So I have a small disclaimer before we continue. I don't have a degree in computer science or engineering or whatsoever. I am not a data scientist. I have no idea how a model works. None. I have even no idea if someone in the world knows how a model works. I used to copy code from Stack Overflow. Anyone else? Good? A lot. And now use JetGPT for the same reason. And to get the story straight, this is not the end of my story. So what I'm gonna show today has an objective. I did not make the objective. I did not finish the project yet, but yet. So this is the beginning of my journey. That journey kind of had to do with this. So I have a thing for GPUs. I wrote a book about designing infrastructures with a couple of books, by the way, about designing infrastructures for all sorts of solutions that have GPUs. And my thing for GPUs started with this thing. So anyone recognizes the GPU? Which one?
3.
No, 1. What's really cool about this GPU was that if you had that game, so anyone recognizes the game?
Quake 2.
Quake 2. So if you had this GPU, which, officially it wasn't the GPU, but an accelerator, but if you had that GPU and that game and the right API, you got this.
Software rendering.
This is software rendering, yeah, and this is hardware rendering. So the difference an API can make when having hardware at your disposal and software that allows you to use that API, magic. Now, what happens if you, and this is, anyone recognizes the GPU?
I had the money to get one. Is it a time?
No. No, it's a RTX 6000 Ada. I have one of these in my lab. And with that GPU, you have the same game, different API, different GPU, and end up like this. Like literally. Correct. So if you want to play around with Quake 2 RTX and have a modern GPU that supports real-time ray tracing, it's for free, highly recommended. Really, really awesome. But again, the difference that an API can make to a game or an application. Sorry?
Fast tracing, it's not ray tracing, right?
No, this is ray tracing, real time.
Yeah.
Well, you're the 3D expert. I just know how a GPU works.
Also, it's fast tracing, not ray tracing.
So, and then this happened. So anyone recognizes the demo? Yes. Based on a Skylake CPU, and you can see that it recognizes 4.2, roughly 4.2 images a second on CPU. Now, who recognizes this guy? This guy is Ian Buck. Ring a bell? He's a VP at NVIDIA and the inventor of Brook. Anyone knows what Brook is? No, it's the predecessor to CUDA. So Brook he invented Brook, so it was the first language that let you run computational instructions through an API to a GPU and run matrix computations, basically. And what's really cool about that is if you do the same thing on in this case, it's a V100, so it's a relatively older GPU already. But if you do the same thing, you can roughly have like 870 images recognized a second. So that's a thing. Now what happens, and this is the first bridge to Kubernetes, and the first time I ever heard about Kubernetes. So this is a demo they showed at NVIDIA GTC, I think in 2020. And honestly, I think this is a kind of a architecture kind of demo, maybe scripted, I don't know. But the whole thing is, if you now, instead of just one node running that workflow or that application, scale it up, you recognize nearly 7,000 images a second. And this made me kind of wonder, like, is this true? Is this architecture? What is the whole magic behind Kubernetes? A couple of months ago, I had an interview with Deshaun Carter. Anyone know Deshaun? Okay, he's a Spring advocate, but also really nice guy, and he's all about developer experience. So he told me about what is developer experience, and to him that was Git commit. That was all. That was it. And taking like the learnings from, or the information I showed just in the video about Kubernetes, the stuff that he told me, I wanted to know more about that developer experience. And what you also need to know is that in the last couple of years, in the last roughly 7 years, I've worked with different types of customers as an architect, mainly with data scientists, because they hired us to build a platform for them to develop things. In case of Airbus, where I work with Rob, they logically develop things for planes, models for planes. At the Dutch Cancer Institute, we built a platform they could use by day for general Windows workloads, but by night that platform completely switches off from a digital workspace platform to a GPU render or a GPU computation farm, where they can batch schedule image recognition, for instance, of MRI images. And at the last customer, the UMC Utrecht, we work with them to basically create the same as the Dutch Cancer Institute. And all of the conversations I had in the last couple of years also came across. So I had the wonderful, awesome videos from NVIDIA, then the conversation I had with Sean, all of the learnings from the data scientists and the AI practitioners at the different customers. And although it's all awesome, there's a huge mismatch there. Because what we quite often think is that a data scientist is a developer, but he or she, or technically spoken, it's not. They do complete different things because, and as you all know, a developer builds, creates software and applications, write code, and they push code for a living. They use CI/CD tooling and solutions like Kubernetes to bring code to production. They don't care about the infrastructure and they don't care about the infrastructure. While a data scientist collects, analyzes, and interprets large volumes of data, develops statistical models, and analyze data and detect patterns, which is completely different. And a data scientist, like mentioned, analyzes data and tests in real time, uses AI frameworks, and care a lot about the infrastructure, mostly because they always have an indefinite need for more resources. You have 10 GPUs? I'll use them, like all of them. You have 20? Sure, give them. I'll use all of them. And they have no idea what Kubernetes is. Nothing. At the Dutch Cancer Institute, I worked with 15 different research departments, all with their own data science teams, and they all did something completely different. Some developed on Linux without GPU needs, some on Windows in Python, others did something completely different. And they don't care. They just want to do their thing, and now, and preferably locally with data on their machine. So taking again all of that information into account, I thought I'd throw myself in front of the lions. I want to solve this thing, but I needed a use case, and the use case in this case is the neighbor's cat, Lola. So Lola is from the neighbors. Is a frickin' huge Maine Coon. Anyone know what a Maine Coon is? Biggest domestic cat in the world. Lola is just 1 year old there and probably weighs around 14, 15 kilos. Her turds are bigger than mine. And she shits in my garden. So the objective here was to avoid turds in my garden, to use AI to detect Lola, to master Kubernetes, to learn about platform engineering, and really important, to avoid a war with the neighbors. And also, and this is kind of a side objective, but I always use this meme when I present about AI. I wanted to debunk the meme. So I got a couple of requirements. First of all,
You could have bought a dog.
I could have bought a dog. But yeah. I know, but you know, what's fun about a dog? Well, a lot of things, but I'm a nerd. I want to nerd out. So I needed infrastructure, but there's also something called a spouse acceptance factor, which on average says that it can't cost like hundreds and hundreds of grand. It needed a low power consumption because of the environment. And I wanted to be resilient and preferably fully automated. Also relatively important, I have 2 small children, so whatever I would figure out, it needed to be children-proof as well. So I had a game plan. So I bought a bunch of really cheap second-hand Ubiquiti security cameras. And really cool, I built an application using NVIDIA DeepStream. Anyone heard about DeepStream? Okay, free SDK. You can I'll cover that in a bit, but it's a free SDK you could use for image recognition in real time. It has its own pipeline, which you can tweak and tune based on whatever you want to do. If you have just one feed, multiple feeds, if you're gonna don't do video feeds, but a large number of pictures, photos, you can do whatever you want and configure the pipeline in such a way that whatever happens, you can trigger it, but also use different types of models. You can decode the streams or encode them again, and I'll show you in a bit. And what I wanted to do with DeepStream is, first of all, I got a bunch of these laying around, and I use those are Google Home displays, and I use them to run my home automation stuff in. I get notifications on those displays if someone is at the front door, or if the baby is awake, or like whatever happens. So I wanted, if Lola is doing something in my garden, also to get a notification. So I do that through Scripted, which lets you import every single type of RTSP stream and export it to whatever you want. Could be Google Home, could be something with Apple or AWS, or doesn't really matter. I also have Homey. Anyone uses Homey? Oh, a couple of hands. So Homey was one of the first home automation platforms built. I bought it through Kickstarter, and it lets you talk to different types of home automation networks, types of solutions like and you don't need a bridge. So this acts as a bridge. So if, in this case, Lola is detected, and I'm using an inferencing app to detect it, I want Homey to send a push notification to the Google display, and on the notification, if I hit a button, the feed automatically pops up. But what I also want is Homey to trigger the watering system to send a lot of water through my watering system and basically get rid of Lola. So that was the game plan. And with all game plans, so you have, I did a personal assessment a while ago, and I am really good at starting things. Really good. But along the way, if I get hurdles, that might end up in a challenge. So I found those challenges, and in a normal presentation I would normally give, I always end with lessons learned. Mostly just one slide. That's it. Lessons learned at the end of the story. In this case, I'm gonna directly dive into the lessons learned. There were a ton of lessons learned. So first step was to build the application, the actual app. And like I mentioned, I used the DeepStream framework, and DeepStream is being used by a large number of enterprises globally. It's one of the most popular image recognition frameworks for real-time video recognition. And it's just an SDK, and you can feed it with any type of model that you use, that you would like to use and would like to train. But it's fully open source, and NVIDIA created a large number of materials around it for you to use. So looking at the SDK, it supports all sorts of, or it has all sorts of different steps in the pipelines in which you can both use GPUs, CPUs, but also different types of accelerators if you have them. And really cool, you can run them on tiny IoT machines, on powerful workstations, cloud, whatsoever. So it's a really cool SDK. And the way to get it is through NGC. Anyone heard of NGC? Ooh, okay. So ngc.nvidia.com is a online repository of everything that NVIDIA and the community around NVIDIA built. And you can download all individual platforms for free. So you don't need to pay anything. And what's really cool about this, so at the Dutch Cancer Institute, when we started there, NGC didn't exist. And one of the data science teams wanted us to implement TensorFlow, one of the deep learning frameworks built by Google, open source. And in order to get TensorFlow fully installed, we went through 3 weeks of troubleshooting, and because if you install a certain version of TensorFlow, you need a certain version of CUDA and a certain version of the CUDA deep neural network and a certain version of this and that, and it was one big shitstorm. A year later, they built NGC, and what you now do is basically you pull a TensorFlow container, and NVIDIA makes sure that every single framework, driver, SDK, everything you need is packaged into a single Docker file, and it's all cross-tested. So you pull it, and you know that it works. It just works. So that's really cool. So DeepStream is available on this. Different types of flavors. There's the DeepStream flavor for powerful GPUs, data center grade GPUs, but also for GeForces. But there's also one for Jetson Nano. And with Jetson Nano, I could fill in the power consumption requirement, the cost requirement, but also the coolness requirement. So I think those are really awesome. Who ever played around with Jupyter Notebook? Good. Many hands. So Jupyter Notebook is basically part of every single NGC container you pull, and it's a really awesome solution to, well, not just play around with deep learning, but also like in real time figure out if you come across something that just doesn't work, it'll help. It can make you help to troubleshoot or to quickly test something or to see something in real time. And what I did is use DeepStream to create and I apologize on forehand that all of my demos are recorded, and there's a logical explanation for that, and I'll show you that in a bit. What you see here is that...
I apologize for recording that. That's
No?
a good plan.
Okay. Well, this was part of the game plan. No, so what you saw here was a pipeline. What you see here is a configuration file specifically for the type of model that I use. And these are labels of objects that could be recognized. And what a data scientist on average does through this is manipulate these individual configurations or the labels or the model or everything in real time. There's console access to Bash within the environment of the container, so this is extremely powerful. So I built the application, and I'll show you that in the next demo, but so far that was done. Now the next step was to build the actual infrastructure. So what I did is I bought on Marktplaats, the eBay of the Netherlands, 2 second-hand Jetson Nanos for roughly 100 euros a piece. I had an existing NUC. I bought a 35 euros Ubiquiti switch, and I had some Lego Technics laying around. So I built kind of a, I don't know, mini rack. But the cool thing is that it fully works. So it has Ubuntu 20.04, K3s, and Jetpack, which is basically a full-blown package with everything you need to do something with deep learning on a Jetson. And the cost of everything was, well, nothing. So the spouse acceptance factor was also covered here. And the best thing of everything, it just, if I run both Jetsons full-blown, high-powered, fully powered, it only consumes 30 watts. So that's, I think, also really cool. Now, quickly, a Jetson has, and I think this is the most important part, has 128 Maxwell cores. So 128 CUDA cores that can run matrix computations. And really cool is that it's really powerful encoding and decoding device. So quite often, if people talk about the GPU does a lot of things, rendering, maybe some computations, and encoding, decoding, but those are different components on the actual card. But this one has really good encoding and decoding chips. So one lesson I learned was that in order to get the full power or the full performance out of the thing, you need to put a jumper there and not use the USB power socket. but you need to have a full-blown barrel connector to it. And then instead of 5 watts, it does 10. Quickly, Jetpack, already kind of mentioned it, but Jetpack has everything you need to get started. CUDA drivers, all of the individual frameworks. It has some SDKs installed already, really powerful. Next thing I needed to do was install the container runtime. I didn't know that. I thought, well, install Kubernetes, deploy a container, and we're done. Well, apparently not, because the containers are unable to talk to GPUs at that moment. So you need to install a container runtime from NVIDIA and test it. So that's basically what I did. Install the runtime, and I'll share the slides, by the way, later on. And if you get a result pass, then it's good, then you're done. So I did this on all individual machines. Nice. Install K3s. It won't take long, simple as that. And that was literally the case. But still stuff didn't work. So apparently, and I didn't know that, but you need to run then a device query and a configuration. And again, I'll share the slides later on to ensure that the GPUs can actually work in the cluster. So after adjusting some things, I got a result is passed from both nodes back, so that was really cool. Then I did the same thing on the pod to actually make sure that, or create a pod so the device query could run on the cluster as well. So also, result pass, really cool. Next thing I did was deploy a container of TensorFlow. So this is based on an NGC container to test actually if TensorFlow works, because that's one of the primary tests. I can access my drivers, I can access my GPUs, that's all fine. But if my applications are unable to import some kind of GPU acceleration framework, then I have a challenge. So also pass. And the last 5 slides, maybe 6 slides from the moment I built the infrastructure until here, took 2 months of tinkering and playing around and starting all over again and again and again. But finally I had an infrastructure. So the next thing was to run the application on K3s. And I know that I am doing things here that I shouldn't be doing, especially looking at, first of all, networking, because I'm now tying the network of the container to the host. I know, but that's on the roadmap. And I am certainly not, I shouldn't be allowing root this, but it's all demo purposes, right? So first demo, I'm going to show the RTP stream, start the pipeline with a ResNet model, and show the utilization of the Jetson node, but also show the results in VLC. Because what DeepStream does, it imports an RTSP stream, but it outputs it as well. And one of the quickest ways to check the stream is through VLC. Right, so here you can see and the demo is recorded yesterday. You can see one of the RTSP streams. It's a bit laggy, and I'll explain that in a bit as well. And if I now do 2 things. First of all, at the above section, you can see now, I just intentionally did that. You can see what you can add in terms of parameters to configure the pipeline. And in the below one, I just executed this. So this is the URL to one of the streams. And things that you could configure is, for instance, if you're using H.264, H.265, what the bit rate is. And if we go to one of the Jetsons, you can now see, and it's really cool, this part of the Jetpack. You can see all sorts of stats in real time. So you can see here there's a Python 3 based application running. That's the DeepStream app. You can see here what the encoder and the decoder are doing. You can see the temperature. And in the meantime, the application is running. And you can now see that I am detected. Again, it's a bit laggy. But first step, train model. inject it in deep stream, import an RTSP stream, detect stuff. It works. Next demo.
The fact that it's lagging is because is the quality of the cameras, is because you adjust now that it's not so powerful?
Give me 3 minutes.
Okay.
I'll show it. So next thing, this is my cat. Yeah. Right. So I needed to teach the model what a cat is, apparently. So teaching ResNet what a cat is quite difficult because it's an older framework. But there's a better way to do this. Anyone heard of YOLO?
Yeah, of course.
Right. That's not hashtag YOLO, but it's a combination of things, but it's mostly a model, pre-trained, and it stands for you only look once. And what's really cool is that YOLO is much faster than ResNet. ResNet is an RCNN, and it's also much more accurate. Result of that is, and my cat didn't want to work with me, obviously. So I had to get her. But you can already see that the frame rate is much better. Bit rate is better. It's smoother, simply because YOLO works a lot better as well. So that miserably failed. The objective was that cat. And if, yeah, well, let me show you the one of the last demos. I recorded this 2 hours before I came here. Right. It recognizes a chair. Then I thought, what if I would take away the background? Same thing. And there you have it. It recognizes a cat. Not my cat, but a cat. So to me, the moral of the story is a couple of things. First of all, the Dutch national team lost the first game, but they won the tournament. So this is how the whole cat situation at home works for me personally as well. I lost the first game, but I'm surely going to win the match. So the preliminary conclusion is failed for now. I got a couple of next steps. I'm going to train a custom model. So YOLO allows you to train a custom model based on images you take. So I need to, I don't know, find a way for me to take a shit ton of pictures of Lola. Then I'm going to implement networking like it should, and load balancing as well. I'm going to surely learn about pipelining tools because I want to put my code in Git, and with every update I build or every new version, I want to automatically build it on my platform as well. Share everything on GitHub, and hopefully someday come back to present the results. So a couple of valuable resources I would like to share. First of all, if you want to play around with this, simplest way is to run Launchpad on the NVIDIA side, fully for free, but they spin up labs for you where you can learn about deep learning, about computer vision, all sorts of stuff. And really, this is one of my go-to places to learn about new things. The same with the Deep Learning Institute. If you have a Jetson Nano, they have an awesome course to get started on deep learning. It's a full day course where you get all sorts of tools pre-installed on the Nano to basically go through the whole process. And really cool. There's a link on there's a page on or a blog on the Suzy site, which explains most of the stuff that I went through in a blog, and really, really valuable information. So finally, my favorite lesson learned is the difference between screwing around and science is writing it down. So where I started the first couple of weeks of playing around, breaking stuff, didn't know what I did wrong or did right. The last couple of weeks I've been creating dumps of every single thing I did, and now kind of master writing down the word Kubernetes. But it's a cool journey. I love being in the driver's seat again. Are there any questions? Thank you.
Questions?
If you have an NVIDIA GPU, like 3000 series, or can you play around with some stuff?
Yes, 100%. So everything that supports CUDA 10.1 and newer, which was released in the time that the GTX 1080, I think, or 1060 was released, that's already 10 years old. So everything that's newer and has CUDA support, awesome.
Yeah, you maybe have to add some variables that accepts unsupported cards for the older NVIDIA ones.
No, so if you look at the NVIDIA side, and for instance the Deepstream framework, there are multiple different versions of Deepstream. I used 6, but they're currently already up to 8, I think. 6.0.1 was the one that was the newest that was supported for Jetson Nano, which has a Maxwell, so a pretty old GPU in it. But if you take a look at, if you want to play around with Deepstream, just take a look at the supported CUDA version and relate that to the cards that you have. Then you'll definitely be fine.
Okay, thanks.
Yeah.
No questions?
If not, I'll be walking around here.